Okay, Accelerated AGS3 final study guide. This is a long one, so it's probably going to be split over multiple videos. So we're going to start with Module 1 with inverses. It says find the inverse of f of x. Yeah, okay, so we're going to think of this as y, and then we're going to switch x and y. And then we are going to solve this for y. So we'll subtract 3. And then we're going to square both sides. And remember, when you do that, that doesn't turn into like x squared plus 9 or something. Okay, don't do that mistake. And then we're going to add 1. And there's our answer. 2, same thing. Okay, only one tricky step here. We've got to multiply both sides by y. And then we're going to divide both sides by x. And you'll see we get back to the same thing that we started with. Okay, f of x and g of x are inverses of one another and drawn on the same graph with the same scale on both horizontal and vertical axes. Which of the following would be true? Okay, if 2 are inverses of each other, this wouldn't make sense. Translated up 3, nor would rotations, but a reflection over y equals x is definitely true, as we'll see later in the test or study guide. Okay, f of x and g of x are inverses of each other. F of negative 2 is 13. So the other function, the inverse, remember if you have one where it goes like negative 2, 13, and this was f of x, then the other one, like g of x, would be the opposite. So that would be g of 13 is negative 2. Another thing to remember about inverses before we move on is if you have f of x and g of x, and you have like f of g of x, and when you plug them into each other, do remember that they both should simplify down to just x. So the same thing would happen if we plugged f of x into g of x like this, then you would get, that would also be simplified down to x. Okay, all right, here's the, what we're talking about the reflection over y equals x. So that's y equals x, and that one would reflect. And that one would reflect. This would reflect onto itself. So if you're ever not sure, you can always graph things and see if that's true. This one should reflect onto itself like this. It should not do what it's doing. Okay, let's see, that's 2 pages down. Oh, just realized I did that out of sequence. So I downloaded, or I took screenshots of the whole thing, and I'm zooming in on each one. So I zoomed in so close, it's going to be a little bit out of order for just the first part, but I'll try to stay up on that from here on out. So we got to go back to, remember this one, don't worry about invertible for the final. Okay, f of x equals 3 to the x power. What are the domain and range of its inverse? All right, so remember there is a relationship between domain and range on a function and its inverse. So the domain and range of the function are the same for the inverse, except they're switched. So if we figure out what this is over here, all we have to do is switch the domain and the range. So I start thinking about the domain of this, and I think about, well, what numbers could I plug in for x? I can plug in anything I want. Because I can plug in negative numbers too, but when I do that, they don't give me negative numbers. When I plug in the range, the smallest thing I could get, let's see, if I plugged in like, negative 10 or negative 1,000 or something, it just give me 1 over 3 to the 10th, or a really small number that approaches 0, but it never gets to 0. And if we plug in huge numbers, we get huge numbers. So that's the domain and range of the original. So the inverse would just be this switched. So this would be the domain. So that means it must be this one, and then that's the range. Yeah, so it's C. Use f of x to find f of 1 and -5. Okay, so in f of x, I know that x and y are switched. So when I plug in, let's see here. So when I have the inverse, when I plug in -5 to the inverse, I would get something. Okay. So you could think about like what the inverse would look like. Or I could also think about...
Emily Ruggles, please come to the main office.
So here's the inverse, and here's the, just call it O for the original. So when I plug -5 into the inverse, I would get something, right? And then a -5 would be over here in the one that we have graphed. So now I'm thinking about like, where is the graph at -5 for y? Here's -5. It's here. What is x at that point? So x at that point would be, so here's -5. It would be -1. So it would be -1, -5 for the original, and then that means that the inverse is this, okay? So here's what we have graphed in reality, okay? Here's the inverse. So that tells us that f of -5 must be -1. And the answer is C. Which of the following is the inverse of 4 to the x? Okay, once again, we're going to switch x and y. So I'm going to have a logarithm, and that logarithm has a base of 4. The answer to the problem is x, and the exponent is y. Which of the following is not true about the inverse of the function? Okay. So I just know that the domain and the range of a function are flipped. So I can tell just from doing this a lot that this one right here, I know the domain and range is infinity, -infinity because it's linear. I can plug anything into it. So the domains and range would be flipped, would still be -infinity to infinity. So both of these have to be okay. And then I'm down to these two. Now, you can definitely go ahead and do and solve that for y. And then you could see that the slope or the rate of change is not 1/3, but I don't want to do that. I'm going to say that the x-intercept of f of -1 is 5 to 0. So that's of the inverse. So of the regular function, it would have to be switched. And if that's true, I know that this one would be okay. So if I take 0 and I put it here, do I get 5/2? Yes, I do. Now the page is way too marked up. So the answer is C, because all the other ones worked out to be okay. Okay, I'm going to stop the video here and make a new one.